Okay, a common question that you're going to be asked is something about power going up a stairs or up a ramp. Let's, for argument's sake, say that this is a set of stairs and the 70 kilogram person is going to go up the set of stairs. He's going to be timed doing it. So an observer is timing how quickly this 70 kilogram person can get up the stairs. And after doing these trials, say 10 times, we find that the average time taken to get up these set of stairs is 7.4 seconds. Alright, so going up these flight of stairs, 70 kilos, and it's going to take 7.4 seconds. Now, because we're asked to work out power, we need to know what that is. Well, power is equal to work or change in energy over the change in time. We've just seen that we've got a change of time here, but we need to work out the work done. The work done is the work to get from this elevation to this elevation. So of all of these numbers, the only one we really worry about is the change in height, because the energy changing here is the gravitational potential energy. So at this point, which is the floor, 0 gravitational potential. At this point here, though, there is some gravitational potential. And so that's what the question is really asking. What is the change in gravitational potential and how quickly has that occurred? So therefore, what was the minimum power? Now the power will actually be higher than that because of course some of this change in energy, so some of this work done, will be used to overcome friction, because of course he's not wearing a frictionless suit or anything like that. He's got to actually overcome friction as well, which requires some work. So we're finding the minimum power of this person. The power will actually be higher because more work will be done. Never mind, let's say that the question says assume no loss of energy due to friction. Okay, so we'll go with that assumption for now. So we have to find a change in energy. So what we do here is change in potential is the change in energy, which is the work. So the change in potential is the mass times gravity times the change in height. We've got all of that data. We've got 70. You have to know that this year gravity is given the value of 10 newtons per kilogram, and we're given a height. These other numbers actually mean nothing. They have no relevance to the question at all in this particular question. Alright? So I can go 70 times 10 is 700 times 8, so 5,600. No, there's my maths right there. It's 5,600 joules. That is also the minimum work done. But the question would have said assume no energy is lost due to friction. So it will be 5,600 joules. So I then put this into here. So I go 5,600, because I want it in joules, divided by, well, it took 7.4 seconds, and I'm going to get joules per second, which is the same as watts. Not watts, but watts. Alright, so I'm going to need someone with a calculator to do that for me, please, because that's a bit beyond me.
756 is 7,000.
So 757?
Yeah.
Cool. 757 watts. And so that's how to work it out. Probably, to be honest, with the values given, I'd say 760. I'd round it off again, but that'd be fine. The only reason you'd use this one here is to work out the force of each step, basically, because of course they're pushing that way. Alright, so that would be something else. Or if you're told, well actually, the person used 10,000 joules of energy, and then you could find a difference in energy and work out how much friction, because friction is operating in this direction, which is on the same plane as that direction. So let's say, for argument's sake, that 10,000 joules of work was actually done. Not 5,600, but 10,000. So that means there's 4,400 joules wasted, as it were, to overcome friction, which is going in this direction here. Oops. Also friction goes in that direction. Now, I could actually find out some more information again. Okay, so I could use the fact that I've got a force, and I can find out the size of the force that's friction because I have a distance and I have an amount of energy. So I can find out how much force of friction there was to overcome. So there's two ways to look at these questions, so be careful of that. If it's a power question, you're going to be looking at the height because you're looking at a change in potential energy. If, however, it's a friction question, you need to look at the hypotenuse because that's in the direction that friction works. Because we're trying to go up on an angle, it's trying to stop us doing that. Friction works against movement or against motion. Alright? So ramps and hills and stairs and that sort of thing, be careful of what the question is asking before you actually decide whether to use the hypotenuse or the height. Very rarely will you be asked to use the adjacent or the distance along the bottom. That's very, very rarely used. That's normally only used if we don't know the hypotenuse. All right.